Hello. Hello.
Hello.
Hi, Prof.
Hello.
Time to continue.
Okay. Mr. Yahaya, are you there?
Yes, I'm here. Am I being heard?
Oh, okay.
Very good. So good
You are.
morning. Good morning, Mr. Yahaya. Nice to see you here on
Thank
the
you, Prof. Good
conference.
morning.
Yeah, appreciate coming in here. Um, so I want to introduce to the audience Yahaya Mohamed Sani. He is from Makerere University from Kampala, Uganda. And he will be talking about predicting the effect of human mobility on COVID-19 cases transmission using ANN CNN hybrid modeling. So, Mr. Yahaya, the floor is yours. Just go ahead. Thank you.
Thank you, Prof. Let me share my screen. Hello. Can you see my screen?
Yes.
Yes, good. Prof, once again, good morning, and other members of the panel. Thank you very much for finding my paper worthy of being presented at the ongoing PanAfricon AI Conference 2023 taking place in Ethiopia. So this morning I will be presenting my topic entitled Predicting the Effect of Human Mobility Factors on COVID-19 transmission using hybrid ANN and CNN model. So the structure of my paper is as follows. Start with introduction, the study objective, the motivation, contributions, methodology, results, and conclusion. By introduction, COVID-19 is a contagious disease caused by the latest coronavirus discovered in Wuhan, China in December 2019. So COVID-19 has caused the world's largest economic recession in history, locking up over one-third of the world's population, if not half. So the spread of infectious diseases such as COVID-19 is influenced by travel patterns and mobility as well. So, however, the extent to which mobility influences the increases in the progression of cases of COVID-19 in the world, including Nigeria, is unknown. So, Nigeria and other countries in the sub-Saharan Africa, like the rest of the world, introduced several measures such as lockdown in order to halt the spread of the disease. So, however, it was noted that mobility factor during this period is critical to the study for tracking the distribution pattern as well as predicting the number of cases in different states of the country. So this provides an opportunity to provide the impact of mobility restrictions and thereby devise ways of ensuring effective measures to curb this disease. So from the foregoing, the importance of mobility in the spread of infectious disease becomes evident. So given the likelihood of other emerging infectious diseases in the future, insight from the current epidemic or pandemic on what worked, what failed, and what needs to be improved are needed. So in this study, we are motivated to identify the relationship between human mobility factors and COVID-19 confirmed cases in Nigeria, and to also develop a hybrid ANN CNN learning model to predict the effect of human mobility and COVID-19 confirmed cases. So the contributions in these studies is summarized as follows. One, a hybrid CNN model was developed to predict the impact of human mobility factors against the spread of COVID-19 confirmed cases. And two, the formal representation, the hybrid CNN model using mathematical equations was developed. And three, an architecture of the developed hybrid CNN model for predicting the impact of human mobility factors, the spread of COVID-19 confirmed cases was also designed. So, and Spearman heatmap correlation heatmap was used to visualize the correlations in the human mobility variables and COVID-19 cases. So, and developed a hybrid ANC model was evaluated alongside 5 other models, single models, state-of-the-art models, based on the performance evaluation metrics of absolute values, mean square errors, root mean square errors, which are standard for evaluating the performance of machine learning models. So, in literature, we have this Nasri et al. 2021, which use Arimax and Arima and Box Jenkins. And the strength of the model was the model was able to predict the relationship between intercity travel trends and COVID-19 cases. So the limitation was that it had little to no direct impact on COVID-19 travel patterns. So Nipaba 2021 used multivariate LSTM, long short-time memory, forecast COVID-19 infection cases and mobility just between 1 to 4 weeks. So the model's ability to forecast dynamics for the additional time was not properly assessed. So and lastly, Saba et al. Use winter, Sarima, random forest, K-nearest support vector regulations, and decision trees, polynomial and gradient boost regression to forecast 10 days ahead of COVID-19 and human mobility under lockdown situation. So the forecast, however, had only a brief period of 10 days, which is sufficient to reveal the true pattern of the relationship between COVID-19 cases and human mobility. So the dataset and description used in this study was COVID-19 confirmed cases 90,786 covering 6 states, which were quoting from Nigerian Center for Disease Control and Prevention and global mobility data, which comes in 6 categories. That is, it shows that it starts with the baseline, which is the zero level. So it comes in 6 categories, which was foods and movement of people to food stores, that's groceries and pharmacy, parks, amusement parks, retail shops, and recreation facilities like transit, local transit, within the area of tourists, movement of people to workplaces, movement of people to their homes, in addition to air travel passengers and air travel passengers departure data. Well, the global mobility report it shows the increase of movement of people along these 6 categories. Either the increase or decrease over time. So the area of these studies include Adamawa State, Igu, Federal Capital Territory, Abuja, Nigeria, Kano State, Lagos, and River State. These are states that are represented because Nigeria has 30 states, and these are states. So each of these states were carefully selected from the 6 geopolitical zones of Nigeria because they were strategically located, and they have all these variables that or factors or data sets that are required for this research. So, and after collecting the data set, discovered that the data set were sparse, they were zero inflated, and these zero inflated values have a negative impact on machine learning prediction. So in this regard, these are 2 steps. Those 2 steps feature kind of feature selection feature scaling techniques, whereby these are a kind of spatial temporal data which have space and time. So in this regard, the X is representing our data set. This data set covers a period of 1 year between the 1st of May 2020 to 30th of April 2021. So like now, have X to represent the COVID-19 data, the one to the last date, from the one to the 366 days. Is it? So you a kind of transport a kind of rescale the data using min-max over time. That is the min-max scale data on the basis of 0 to 1, where 0 represents minimum value and 1 represents maximum value. So after that, you scale it. That is one step. This one step is using maps absolute value, which scale the data set on the basis of -1 to 1. So the maps absolute value use the maps absolute value of the numbers. And the reason why these are coming up with data scaling method is very crucial in this regard is the fact that these zero values in previous stories used to be discarded, but there is no fairness. We have to entrench fairness and give all the data set, regardless of their nature, equal opportunity to participate fairly in the prediction process. So this is the equation 4 represent the transformed data, where X represent the observations at time t and X prime of t is the scaled COVID-19 data for both equation 1 and 2, that is step 1 and step 2. So this is the heat map correlation for different states. As you can see in this Adamo state, the COVID-19 confirmed cases has some kind of low relationship between mobility and many cases may be big, but they are positive to some extent. And here in the state, it has weaker relationship. COVID cases has a weaker relationship with the mobility factors. But here in FCT, which is one of the epicenter of COVID-19 in Nigeria, it has a strong correlation with arrival of air traffic passengers, strong correlation with because as we are living other airport across the country, a activity that infected the population could kind of transmit the virus in their new locations. Likewise, movement of people to retail and recreation centers, so movement of parks and workplaces during a kind of when movement restrictions were that's intermittently. It's also a factor that influence the progression of our COVID-19 confirmed cases. Likewise, in Kano, the same thing applies. It has COVID-19 confirmed cases has a kind of a strong correlation with human mobility. So likewise, in order, so the relationship varies from one state to the other. So in this regard, once a correlation analysis is being done, it is pertinent to come up with a model that have a kind of feature scaling, feature selection capability. So in this regard, multiple linear regression is not ideal, in the sense that multiple linear regressions consider both dependent and independent variables to have a kind of strong correlation, in which scientifically is wrong. So coming up with a particular model that selects two based on their variables based on their importance is critical. So in this regard, in the full paper, I come up with 5 different individual models, which include multiple linear regressions, artificial neural network, convolutional neural network. I also have long short-term memory LSTM. So and these are developed hybrid of and CNN models. So all their strengths and limitations were all highlighted in the full. So this is the proposed or the developed hybrid and CNN model. This let's supposing X map 1, whereby the X is the input and is the output. So the T represents, so X of T represents X1 of T up to the last day, from day 1 to the 65, 50 days. While T represents the output of the prediction of each day that this input were inputted into the model. But the input, of course, include this 6 input data set and the last 2 travel passengers data, arrival and departure data. So for each data samples used, 80% of the data set were used for training. That is from the 1st of May to up to 296 days were used for training. While the remaining data sets, which constitute 20%, that is 73 days, were used for testing. So the testing phase was repeated to estimate a set of future cases as follows, whereby Y is supposed to estimate of X1 of TI, X2 TI up to the 72 days. Where 1 is less than equals to I, and is less than equals to M. This is of the hybrid and CNN model. So this is the component of the artificial neural network, whereby you put the dependent variables, which include retail movement of people to retail locations, supermarket, pharmacy, parks, up to air passengers. So this is the kind of processing layer. This is the process layer. This is the feature extraction layer. Because one, the choice of this hybrid was characterized by the fact that the two models, for the fact that deep learning requires a huge amount of data, it is partly to stress at this junction that artificial neural network can deal with, despite the fact that it's a component, is a type of or category of deep learning, it can deal with limited amount of data, but it has quicker feature extraction capability, whereas convolutional neural network is pride itself in the feature a kind of extraction and selection based on their importance. So that was the reason. And after the experiment, it was observed that the hybrid model performed better than the individual single models. So the hyperparameters used in this study were the learning rate of choosing that the better result was 0.001, and the activation function that was used was L, which was a nonlinear function, because the relationship between dependent and independent variables are linear. So that was why the ReLU was carefully chosen as an activation function. So the optimizer that was used in this study is Adams. The approach were experiment were completed. The experiment was completed after 100 approach, and the batch size used was at 2, and the loss was MSE. So the regularization was L1 regularization. L1 regularization has ability to a kind of select variables based on their importance, and it also helps overcoming the challenge of overfitting the model. So this is the result of all the 6 models used based on MSEs metrics, as can be seen. The hybrid model of all the 6 state areas of study has the lowest kind of MS values. So the values that were recorded, all the metrics, they are the loss, because during the course of the experiment, there were a kind of result for validation loss, and so the test loss was so as can be seen from the table, the hybrid model performs better with the lowest MSEs for the state using on all the state of study. So likewise, in the main absolute errors, the hybrid model have the lowest main absolute errors compared to individual models, which include multiple linear regression, artificial neural network, CNN, LSTM, ASU, and the root mean square errors, evaluation metrics. The hybrid model also perform with lowest RMS for all the states, and seen from the result reflected on this. So these are the performance evaluation metrics that were used: mean square error, mean absolute error, MAE, root mean square error, RMSE, which is the mean square of mean absolute mean square error. So, and in conclusion, this study will have predicted and analyzed the evolution of confirmed cases, incidents, and vulnerability factors in 6 states in Nigeria, whereas during both lockdown period and when period when people mobility were restrictions were lifted. So, however, the 300 studies were affected by irregular component, which is very challenging scenario for additional model that only uses historical information. So, therefore, in order to predict the regular component scientifically, and to prove scientifically well that it performs better, so hybrid model was developed, and our results shows that based on MAEs, MSEs, SEs, this information improved the prediction of this unstable scenario. They developed hybrid and CNN. Thank you very much for this. So I'm available to take any questions that may arise.
Yeah, thank you. Yeah. Thanks a lot. I don't know about the others I had here. You are welcome. But I don't know about the others, but I had some problem with the audio. It was a little bit, it had a lot of dropouts.
Okay, sorry. That could be due to network.
Yeah, but we could take it from the slides, I think, in most cases. So, yeah, thank you for the presentation on how to predict COVID cases by mobility data. I have maybe one or two questions before we start a round of general questions for understanding what exactly you used as data. You had input data called like parks or like supermarket, pharmacy. What kind of data are those? Are these the people that visited parks, or and how did you get the data from? Is this available through Google, or can you explain on that one? What does it mean?
Yes, I got the data from Google made available this Google Mobility Report data, which data set of that kind of track the location of people that use their smartphone. It releases this data for countries and states. So for the purpose, the idea behind it was to aid in the COVID-19 research during 19 era. So it was going from Google released for a particular website, and the COVID-19 cases that was used in this research were also from Nigeria Center for Disease Control (NCDC) microsite,
okay,
which are recorded on daily basis. So it comes in three categories: confirmed cases, recovery cases, and death cases as well.
Okay, good. I understand that. It scares me off a little bit to see what Google grabs as data, but isn't that a little bit, misleading? Because you can only measure mobility of people who have a mobile subscription for data services and submit their data to Google. So you possibly miss part of the ground truth, isn't it?
Yes, normally that is how Google has a kind of way of tracking people who has a smartphone and they turn on their location. So it is based on these locations that Google track their locations and release this data on weekly basis. So they update the Google Mobility report data. It's being updated on weekly basis. So it shows movement of people to these 6 different categories of places.
I understand. Okay. And how about other factors like people wearing masks and vaccination level at this particular spot, or the age itself? I think this is also important to do a prediction, but possibly these data are not available, or I guess, yeah, is it like this?
Yes, as at the time that when the research was conducted, it was like vaccination data was not available.
Okay, thank you. So let's open the floor for questions. If anyone has questions, please raise your electronic hand at the top bar of your browser window. So please come forward with your questions. Dr. Fitzum.
Thank you. So my question is, so mobility affects for any communicable disease, right? So how do you think the information you gathered from this work can be applied to any other communicable disease?
Yes, it's true. It can be used to model any other communicable disease, because since the idea behind this research is that it is COVID-19 may come and go, but it is clear that epidemic, pandemic, and human race or human societies are inseparable. So I think what inflicts different societies with epidemic or endemic or whatever over time. So it is a kind of critical to use the experience gained from previous pandemic so that we can be able to tackle future pandemic. So, for instance, if it's the mobility variables that influence the progression of a particular epidemic or pandemic in a particular society, so we can use that knowledge or experience, you know, how to tackle future pandemic whenever they arise. So the research is not limited to only COVID-19 era. It goes beyond that. Did I answer your questions satisfactorily, Doctor?
Dr. Fitzum, is it okay?
Yes, yes, please. Thank you.
Okay.
Yeah.
Okay, any other question, please? Any more question for discussion? Thank you very much, Yahaya, for this very interesting presentation and very relevant. I wish you good luck with the follow-up research on that one. Thank you.
Thank you.
So, Ato Daniel, we have now Mr. Prophet Paul here in the as a guest, and he is ready to give his presentation that we missed this morning. You already got him in. We have enough time. I would like to announce already that we will have the closing session today at 12:20. 12:20. So that is in more than 2 hours. So we got enough time for the presentation of Prophet Paul. And if there's no objection from the organizing committee, then I would simply like to go ahead with Prophet Paul.
Yeah.
Seems to be okay. So let me, thank you, Daniel. Let me introduce Prophet Paul Adebacho for you. He is from Olabisi Onabanjo University in Nigeria. So welcome from the West Coast. He will talk about balancing data privacy and research innovation in medical AI, medical data sharing in African health care. Very interesting topic. So the floor is yours, Prophet Paul. Just go ahead. Thank you.
All right. Good morning, everyone. And it's a pleasure to be here this morning to be able to share with you for what I have on the very interesting topic that I have here for today. All right, just a moment so I can share my screen so everyone can follow me. All right, I presume everyone can see my screen now. Please, can you?
Not yet. Yeah, it's coming now.
Okay. Is it on now?
Yeah, it's on. You can go ahead. We see it.
All right, thank you very much. All right, so once again, good morning, everyone. My name is Adebayo, Prophet Paul. And I'm here to speak on balancing data privacy and research innovation in medical AI. Why I find this topic particularly interesting is because there seems to be a kind of antithesis between data privacy and research innovation, because research innovation is basically based on feeding on data, but data privacy seeks to restrict control or access to information. And of course, we do know that if we are going to launch ourselves into the 21st century, practice where we can have full-time growth and development, we know that data will always be part of the equation. So that's why that's what really got me interested in this topic. All right, so on to the introduction, where I'm going to discuss the key terms What is medical or health data? Here it reads that it's any information which relates to the physical and mental health of an individual or to the provision of health services to the individual. And so it includes first the patient data. Now, the patient data deals with the patient on his individual level. That deals with maybe the outpatients, the inpatients, anyone who uses the services of a healthcare provider, or as we call them as we call them in West Africa generally, we call them hospitals, we call them clinics and all that. So then the second part of medical data would be health systems data. Now this deals with management. So this is no more just about individual based. Now this is based with systems that actually deal with everything that revolves around healthcare, be it in a country, be it in a community. Those are health systems, and these health systems are also responsible for even management of patient information at times. All right.
Prophet Paul, just hold on a second. We just see slide 2. I think already you are on slide 3. Can it be? We see slide 2 here. Is that correct?
Yes, slide 2. Yes. Yes, please.
Okay, then just go ahead. Then I'm mistaken. Okay, just go ahead.
Okay. I was discussing it. All right. So then on to the third aspect of health data, which is the routine public health data, which can actually involve survey, perhaps maybe survey about maternal birth, mortality rates. These are routine public health data that help for the country or the territory, or even NGOs, organizations to plan how they are going to deal with some certain deficiencies in the healthcare system. And of course, we have the health research data, which may include things like clinical data on clinical trials and all that. All right, so for data privacy, this is the branch of data management. It deals with handling personal data in compliance with data protection laws, regulations, and general privacy practices. That's for data privacy. So, of course, data privacy and protection has to do with how we safeguard data for people, for persons, for systems, for companies. Then AI in health, for medical AI, is the application of machine learning, natural language processing, deep learning, and other AI-enabled techniques to support and ideally improve the patient experience, including diagnosis, treatment, and results. However, I would also like to buttress this further that it's not necessarily always about improving patient experience. For instance, Dragon and being released a clinical tool at some point, which could help the doctors to reduce the interaction time with patients and help them to improve optimal efficiency in service. So when we talk about, or when we discuss AI in health, it may not necessarily be about the patient alone, all right? It may also be about the healthcare providers themselves. But in the long run, what it does is that it's beneficial to the patient. All right, so to the third slide. This is us discussing Africa's healthcare in retrospect. For us to be able to understand why exactly do we need the integration of medical AI. Of course, over time, medical AI has not really found its foothold in Africa, right? But even aside that, there are some existential challenges that are still burdening the African healthcare system, which in the long run would discuss our policies with regard to data privacy and research innovation. So what are those things? The first is insufficient healthcare coverage and a significant paucity of medical experts. It plagues sub-Saharan Africa, basically. For instance, for a country like Nigeria, per 1,000 patients, I think we have close to about close to 50 to 100 doctors. And for mental patients, mental health patients, we have 1 to 250,000. So it means that in Nigeria, we have for about 250,000 mental health patients, we have just one doctor or just one mental health professional who can handle it. And you can see how that really burdens the system. Secondly, Africa experiences 24% of the global burden of disease, yet it has only 2% of the global supply of doctors in general. The third is, except for a few countries in Africa, the health sector in Africa remains weak due to poor funding. For instance, the AU sat in Abuja in 2009 at some point and discussed, and then that they wanted to allocate about 15% of the annual national budget to health. But over time, I think it's been only about 2 or 3 countries that have been able to do that successfully. And so that's really one of the things burdening the healthcare system. The fourth is, overall, it's estimated that Africa could be losing up to $1 billion on overseas medical services annually for medical tourism. So, WHO 7 has found that the region has a ratio of 1.5.
I'm sorry, I think we lose your voice.
Health workers, physicians, nurses, and midwives, way below
We cannot hear him. Possibly he cannot hear us also. I sent him a message.
Yeah, I think there is a problem with this voice system.
Yeah. I exchanged messages with him before, and he was complaining about audio not available.
Yeah.
So it seems like he has an internet dropout.
Yeah. It will be better if we go to the conclusion part fastly.
Yeah.
Yeah.
Okay, as long as we don't have an audio from Prophet Paul, let's come to conclusions like
Okay, please stay with me.
You're back to us? Okay. We lost your voice for about 2 minutes. Can you go ahead? You finished slide 3 for us, so you can go ahead with slide 4. Hello?
All right. I'm so sorry about that. I didn't know this. Now you can hear me now.
Yeah,
Okay.
dropouts.
Thank you very much.
With dropouts, just try it.
Yes, I can hear you.
I'm very sorry. The quality is not sufficient to continue the presentation. I'm afraid. I'm very sorry for this. So I would like to encourage you to submit a paper for the publication on our series. But for now, we unfortunately cannot continue this presentation. Too many dropouts and we don't listen anything. But anyway, I would like to thank Mr. Prophet Paul Adebajo for introducing this topic to us. We would have loved to follow it because it's very important to understand these ethical aspects too. So hope he can submit the paper in the proceedings. So with that, unfortunately, or not unfortunately, but we will close the session. First of all, I would like to thank everyone for being here, for the presenters to share their research with us for the audience to be interested in these subject matters, for raising questions and stipulating scientific discussion. Especially, I would like to thank the organizers. We have here Atto Daniel and Atto Fraol, and there are many other in the background that which I know contributed to the technical realization for these sessions. And I would like to just give them a round of applause if it is possible. So feel free to react, send a reaction button. Anyway, I would like to thank the all contributors and the organizers for all the work that had been done. Daniel, maybe some comment from you. All right. Then let me just wrap up a few things. So it has been an amazing event for me already yesterday. I gave some comparison to last year's session, and I think I can state that we improved in many aspects regarding the content, the level of research, and also the spectrum of aspects that have been considered. So it is a big improvement from last year to this year. So I hope that by next year we can again increase the research and compete with other international conferences and research that is going on. So I would like to thank you very much. Especially, I would also have loved to hear the last presentation, because it's important to talk about subjects like, well, is the accuracy of my research, is it sufficient for medical applications? Is it ethically responsible to apply our algorithms in the real world? Because it has consequences. Yeah, every mistake, every wrong diagnosis, each wrong diagnosis has severe consequences. And in some countries, it's regulated by law. We need to ask for the regulation of this, but we need to measure ourselves against the, let's say, golden standards that we find elsewhere in the world. And so this ethical discussion that has been started on another topic by the last speaker, these discussions are important in the same way. So I make this my final words. Thank you very much. I pass it over to Dr. Fitzum for his final word on this session. Thank you all.
Thank you, Professor Akim. I also share your sentiment that this year the works have improved, and like in many aspects, like the areas that people are addressing, and also the quality of work itself. I also agree your sentiment on the application of these proposed works in real life, and how those need to be applied, and how caution has to be taken. One of the like I have said this yesterday, and I want to repeat it again, is in many of these AI applications, the concern of false learning, when you have different types of features involved. One particular research that I asked this question on yesterday was they figured out that the model tends to learn what is easier. For example, like why like if a disease like affects male and female, and if you have that information in the data set, and if the disease affects more women than men, the models usually tend to emphasize that feature instead of like the other features, right? So like these kind of considerations need to be taken into when working with application of AI in health. So like in the future, we hope to see this kind of concerns addressed in these sessions. And thank you very much for all the authors for their fantastic work. And I hope to see them with other research in future Pan-African conferences. Thank you.
Okay, thank you very much.
Samuel, you want to say something? You're just raising your hand to say hi. Okay. Ato Daniel, maybe you can update us on the closing session with your latest information.
As I told you earlier, the closing session is at 12:20. After 12:20.
At 12. Sorry, Daniel. The closing sessions will be held at 12. So Dr. Taye will be the one.
Okay, so it will be at 12 in Addis time, 11 here in Europe or in South Africa. And we will use the same link as for the opening yesterday. So please come and join us at 12 o'clock under the opening session link so we can close this event. All right. Bye-bye, guys.
Okay.
See you next year.
Bye. See you later, like 20 minutes. No, 40 minutes. Bye.